In this video, I will describe the operation of a monostable multivibrator circuit. A monostable multivibrator circuit has only one stable state and one temporary quasi-stable state, and the level transition depends on the external triggering pulse. This multivibrator is also known as one-shot multivibrator. Now let's say this is a monostable multivibrator circuit. A monostable multivibrator circuit will use two transistors, Q1 and Q2. The word mono means single. That means the monostable multivibrator will have single stable state depending upon the transistor across which we are taking the output. If I take the output across the transistor Q1, then plus VCC will be its stable state, and if I take the output across transistor Q2, then 0 will be its stable state. In my circuit analysis, I will take the output across the transistor Q2. Therefore, from now on I will proceed with the transistor Q2. Now, if I take the output across the transistor Q2, 0 will be its stable state, and it will remain at this level unless we apply a triggering pulse T1. When we apply this triggering pulse, this external triggering pulse, the output will go from 0 to plus VCC, or from 0 to logic 1, and it will remain at this level plus VCC as long as the pulse T1 is applied. After that, it will automatically come from 1 to logic 0, and it will stay at this level unless we apply another triggering pulse. So this 0 will be its stable state, and temporarily see, it seems that this 1 is also its stable state due to the application of this pulse T1, but this is not its stable state. Therefore, it is known as quasi-stable state, and this is called temporary quasi-stable state because it will remain at this level during the application of the pulse. Once the pulse comes from maximum to 0, the output will again switch back to 1 to 0. Now this is also known as one-shot multivibrator because here we will apply a single triggering pulse to control the operation of this monostable multivibrator circuit. The operation of a multivibrator circuit will be totally dependent upon the switching property of a bipolar junction transistor. When the bipolar junction transistor acts as a switch, it will have two states, on state and off state. A bipolar junction transistor is said to be in on state if I supply a positive voltage of plus VCC at the collector terminal when the input voltage Vi is less than 0.7 volt. This transistor will be in off state. When the transistor is in off state, the collector and emitter terminal gets disconnected from the circuit. Therefore, this transistor will act as a open switch. Therefore, the collector current IC will be equal to 0. As the collector current becomes 0, the voltage difference between the collector and emitter terminal VCE will be equal to plus VCC. So when the transistor is in off state, I can summarize it. Our collector and emitter terminal will get opened, and the collector current IC will be equal to 0, and the collector to emitter voltage VCE will be equal to plus VCC. Now if I apply an input voltage base to emitter voltage Vi greater than 0.7 volt, our transistor will be in on state or in saturation mode. When the transistor is in on state, the collector and emitter terminal will get shorted. As the collector and emitter terminal gets shorted, therefore the voltage between the collector and emitter terminal will be equal to 0 volt, because we are taking the output we are taking this VCE across a short circuit, and the current that is flowing through the collector terminal will be IC saturation current. So I can summarize this property. When the transistor is in on state, our collector and emitter terminal will get shorted, and collector current will be equal to IC set, and VCE, collector to emitter voltage, will be equal to 0 volt. Now let me describe the operation of this monostable multivibrator circuit. See, here we have used two transistors Q1 and Q2, and I am taking the output across the collector and emitter terminal of the transistor Q2. Therefore this will be our V out, or output voltage. See, the collector load of the transistor Q1 is RL1 and the collector load of transistor Q2 is RL2, and you'll see that the collector of the transistor Q1 is connected with the base of the transistor Q2 through a capacitor C1, and you'll see that the base of the transistor Q1 is connected with the collector of the transistor Q2 with the resistor R1. Okay, and you'll see that I can apply a triggering pulse at the base terminal of the transistor Q1 through the capacitor C2. Now let me describe the operation of this circuit. I will take the output across this terminal and this terminal. With the VBB connected, you'll see that the negative terminal of this VBB is connected with the P-type base, and the positive terminal of this VBB is connected with the N-type emitter. Therefore, initially the base to emitter junction of the transistor Q1 will be in reverse bias, as the base to emitter junction is not forward bias in case of this transistor Q1. Therefore the transistor Q1 will be in off state. Therefore I can disconnect the collector and emitter terminal of this transistor from our original circuit, as it is in off state or in cut off mode. Okay, now if I supply this VCC voltage by closing the switch S, here you'll see that as the transistor Q1 is in off state, therefore the collector current IC1 of this transistor will be equal to 0. Therefore the voltage drop IC1 RL1 across this resistor will be equal to 0. That's why, as there is no voltage drop from this point to this point, you'll see that this VCC will be appeared across this collector to emitter terminal of the transistor Q1. That means initially this VCC will be the stable state of the transistor Q1, or the output of the transistor Q1 will be stable at logic 1. Now you will see that this VCC is applied between this point to this point, and you will see that the R2 and the base emitter junction of the transistor Q2 is in series. That means the portion of voltage that is dropped across this base to emitter junction of the transistor Q2 will drive the base to emitter junction of the transistor Q2 in forward bias. Therefore now our transistor Q2 will be in on state. As the transistor Q2 is in on state, therefore its collector and emitter terminal will get shorted, and we are taking the output across this terminal and this terminal. So our output voltage V out will be equal to 0 volt, and this is equal to logic 0, and this 0 volt is the stable state of the transistor Q2 for this circuit. That means the output voltage of the transistor Q1 will be at logic 1, and the output voltage of the transistor Q2 will be at logic 0, and this 1 is stable state for this transistor Q1, and this 0 volt is the stable state for the transistor Q2. The output is stable at this 0 level. What does it mean? It means that if I keep the circuit intact and does not apply any external triggering pulse, the output voltage of the multivibrator, that means I have taken the output across this terminal and this terminal, will be stay at this 0 volt forever if I supply this VCC in this circuit. That's why this 0 is called the absolute stable state for this circuit. Now let's say when the output of this multivibrator is stable at this 0 volt, at that instant I have applied a positive going pulse at the base terminal of the transistor Q1. What is a voltage pulse? See, a positive going pulse is that it will have a voltage of Vs for a brief interval of time 0 to Tp, and this positive going pulse is sufficient to override the effect of this VBB. That means it will drive the base to emitter junction of the transistor Q1 in forward bias. So when the base to emitter junction of the transistor Q1 is in forward bias, that means it will be in on state. When the transistor Q1 is in on state, its collector to emitter terminal will get shorted. Therefore, the saturation current will flow through the collector terminal of the transistor Q1. As the collector and emitter terminal gets shorted, that means there is a short path between this collector to ground terminal of the transistor Q1. Now our VC1 will be equal to 0 volt. That means this will come to at logic 0. See, as the voltage difference between this terminal and this terminal is reduced to 0 volt. That means the voltage difference between this point and this point is equal to 0 volt. That means this 0 volt will be applied at the series connection of the capacitor C1 and to base to emitter junction of the transistor Q2. As the voltage between this terminal and this terminal is 0, therefore the voltage between this terminal and this terminal will be equal to 0 as long as the input pulse is applied. That means the transistor Q2 will not be in on state because it will not get sufficient voltage to drive the base to emitter junction in forward bias. Therefore it will now turns to be in off state. Therefore I can disconnect the collector and emitter terminal from our original circuit. Therefore the collector current IC2 will be equal to 0. Therefore the voltage drop IC2 RL2 will be equal to 0. That means the voltage we are applying VCC between this terminal and this terminal will be appeared across this collector to emitter ground terminal of the transistor Q2. Therefore our output voltage will now equal to VCC or at logic 1. See, previously without this input pulse our output was stable or it was staying at this 0 level. At the instant we are applying this triggering pulse, our output voltage will have a transition from this 0 to 1 volt. So when the transistor Q2 is in off state, a charging current will flow to charge the capacitor C1 and the capacitor will store that charge as a voltage of VC1. The charging current will flow through this path A, B, let's say this is C and this is D, and as the current will flow in this direction, therefore this terminal will be positive and this terminal will be negative, and you will see that this positive terminal is connected with the base terminal of the transistor Q2 and this negative terminal, see this is a short path, will be connected with the emitter terminal of the transistor Q2. We have applied a input pulse of brief interval and it has a high amplitude. After a short time the input pulse will come from its maximum value to this 0 volt. As the input pulse has come to this 0 volt, now our capacitor C1 starts discharging through this path R2 VCC and the short path R2 VCC and the short path of the transistor Q1. Therefore that voltage will be applied between the base to emitter junction of the transistor Q2 as the capacitor starts discharging, and when its voltage will be greater than 0.7 volt, that voltage will drive the base to emitter junction of the transistor Q2 in forward bias. Therefore now our transistor Q2 will be in on state. When the transistor Q2 will be in on state due to the stored charge of the capacitor C1, therefore our collector and emitter terminal will now again get shorted. Therefore our output voltage will have a transition from this VCC to this 0 volt, and you will see that as the output voltage will be reduced from VCC to 0 volt, that 0 volt, that means the voltage difference between this point and this point will be equal to 0 volt, and that 0 volt will be applied between this terminal and this terminal, and this is the emitter terminal of the transistor Q1, and you will see that this 0 volt will be applied between the series connection of the R1 and to base to emitter junction of the transistor Q1. That means the voltage difference between this terminal and this terminal will be less than 0.7 volt. Therefore our base to emitter junction of the transistor Q1 now will not be in forward bias. Therefore it will now be in off state. Therefore, I can disconnect the collector and emitter terminal of the transistor Q1, and the voltage between this terminal and this terminal, that is VC1, will have a transition from this 0 volt to this 1 volt, and this is the complete operation of that monostable multivibrator circuit. And in the output you will see that whatever the condition of the circuit, our output will again come from this VCC to this 0 volt, because it is the only stable state for this circuit. Only stable state, that means the output voltage will retain its value at 0 volt whatever the condition of the circuit. As this 0 volt is its stable state, that means between 0 and 1 only one of the state is its stable state. That is why it is known as monostable multivibrator. And you will see that for the transition from one level to another, I have applied only a single triggering pulse. That's why it is known as one shot multivibrator. Okay, that's it. Thank you.